Hi guys, welcome to this video. This is Dr. Moorthy working as Assistant Professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics. So in this video, we are going to discuss about a topic called equilibrium of particle. Yes, we know that the engineering mechanics is a branch of science is studying the behavior of object, whether it is in a rest condition or in moving conditions. So further the engineering mechanics is classified into statics and dynamics and kinematics and kinetics. So these things are we have discussed in the previous lecture videos, and in this video the topic called equilibrium of particle. Yes, we know that if you are going to analyze object or real world applications, we need to study whether the object is in a equilibrium condition or not. So if you take a building, it should be in the equilibrium conditions, unless it leads to a lot of issues to the structural environment, right? So yes, we know that this equilibrium of conditions here is the different forces, like the horizontal forces, vertical forces. So by means of adding these forces, it should be give the answer 0 or equal, or it take it as the positive forces are equal to the negative forces. So in that case, we can consider the object is in the equilibrium conditions. So here the equilibrium of particle in engineering mechanics. So if we see here, there are different forces acting. So these forces, by adding or summation of the magnitude of these forces, it should give the constant value or 0. So why the equilibrium of particle? So if you take any application, in that case n number of forces is acting on the system. So by means of adding these forces, it should be in the equal, or like the net forces are equal to 0. That is, the summation of forces is 0. A particle is in equilibrium when the forces acting on it are balanced. So these balanced forces are giving the equilibrium conditions. So here the equilibrium of particle, it includes this different forces like scalar, vector, and the type of forces acting, that is the force balance and real world applications, and the impact of forces. So why the particle in equilibrium? So it is a very important. A particle is in equilibrium when the net forces acting on it is 0. So while adding the n number of forces acting in the object, by means of adding or summation of these forces should give the value as 0, or summation of positive forces are is equal to negative forces. In that case, it is considered as the object in equilibrium condition. Right. Next, the conditions for equilibrium. Yes, the force equilibrium and moment equilibrium. So the vector sum of all forces acting on the particle must equal to 0. So the summation of forces are equal to 0 in engineering mechanics point of view. So sigma f x equal to 0, sigma f y equal to 0. It means the summation of the forces in the horizontal direction or x direction is equal to 0. The summation of forces acting in the vertical direction or y direction are equal to 0. So by adding these two forces, the resultant force should be 0. So the force, it is considered as force equilibrium. In the second part, we can take moment equilibrium. So the moment of the net torque of the system should be 0. So next, the free body diagram. What are the key tools? So the free body is a free body diagram. So the separation or isolation of object from the surrounding object. If you take any system, it somewhat it is related with the surroundings. So by means of doing the free body diagram, we can separate these surroundings. We can take it as a supports by means of acting force vector. Right. So 1D particle equilibrium conditions. If we take here, so the one-dimensional particle, it is in equilibrium conditions. So identity, it is the tension T, that is the identity forces, apply equilibrium conditions, solve equations. So a simple step by solving 1D problems. So what are the forces are acting in the system, and then you can apply the equilibrium condition, that is the sum of forces in the specified direction are equal to 0, and we can use this formula T minus W is equal to 0. By adding this we can take it as the tension is equal to self weight of the object. The next one, it is the coplanar forces. We can take a coplanar. If you take a plane, it's a two-dimensional problem. It is the two-dimensional equilibrium conditions, the coplanar. So coplanar, the horizontal component in the system are is equal to 0, and likewise vertical components are equal to 0. So by means of these conditions, obviously the resultant force of the system are equal, are considered as 0. Yes, so this is the equilibrium condition for three-dimensional object. Sigma fx equal to 0, similarly fy equal to 0, similarly fz equal to 0. So this is for three-dimensional object. And what are the steps need to find to solve the practical application? Right, we need to draw the free body diagram, and we can identify the coordinate system, and by solving the forces in the horizontal forces and vertical forces, and we can apply equilibrium conditions, and then we can easily find what are the unknown forces acting on the system. And with the real world applications like cable supports, truss elements, and suspended loads, so these are the some real world application we can solve by means of the applying equilibrium of particle conditions. Thank you for watching this video.